Hello, Krakruka here with a new video. This will be dedicated to the latest firmware update for PocketAdmins, and also there will be some important channel news at the end. Let's start with the update. It has a bug fix and a new feature added, which is Keystroke Reflection. Keystroke Reflection is a new method for exfiltrating data from host machine to the device. It uses HID only interface and specifically keyboard only interface. And I was initially hesitant to add this to PocketAdmins because 1, I was busy, 2, I didn't think it was really super useful, but hey, USB Rubber Ducky implemented this, and I just didn't want them to have some kind of new capability which PocketAdmin doesn't have, so this is why. Let's see how it actually works now. I will demonstrate this using this example payload here. It's very basic, it has just standard startup delay at the beginning, some commands to turn off all the LEDs at the end of the payload, because we're going to be toggling them, and these two new commands which will actually perform the keystroke reflection. Key reflect start will instruct the device to begin the actual reflection process. That is, from this point on, device will treat any kind of request from host machine to the device to toggle numlog as receiving the bit of value 1, and receiving caps lock toggle request will mean receiving bit of 0. Next, key reflect save is a command which will actually wait until the keystroke reflection sequence is over. That is, either host machine sends scroll lock toggle request to the device, or a buffer of 512 bytes is completely full, whichever comes first. In our situation, we will just manually input the data, so we don't need anything in between those commands, and this alone will do. Now, config.txt has HID only mode, because this is the whole point of the payload, using only HID interface. Now let's actually see it in action. I will now plug the device in. We can see the device was inserted but nothing happened. It is now waiting for our keystroke reflection data. Now the bits are sent one by one, most significant bit first in every byte. Let's send an ASCII letter A. It is encoded as 0, 1, 1, 2, 3, 4, 5 zeros, 1. We don't want to send anything else, so end of sequence. You can see the scroll lock LED was automatically turned off. This was those 3 commands at the end of our payload. Now let's see what we have on the device. Now I will just reboot the device into mass storage mode, like you normally would, by just a long caps lock toggle sequence. Device will interpret it as usual because it already knows the keystroke reflection sequence is over. You can see it showed up. There is a new directory called keyref and a new file 000.ref. It has size of 1 byte. Data inside is exactly what we wanted, ASCII letter A. And the name of the file was created automatically because in payload.txt we did not specify explicit name after keyreflect.save. So this is how it works in principle. Now let's see a more useful example, which is something like this. Now this here is the same payload I have in my example payloads folder in the repository. And this whole thing is essentially based on USB Rubber Ducky example. It does the same thing, but adapted for PocketAdmin and made a little bit more readable, at least for me. The whole point of this payload is to actually automatically send the data, because manually inputting it is no good, obviously. So here you can see standard startup delay, then bring up Windows run line, type in this PowerShell command, enter. This will collect the currently logged in user's username, save it into a temporary file called x.txt. Then do the same thing again, bring up Windows run line, type another PowerShell command, beginning is here, then don't press enter but continue typing, continue again, and this is the end of the command. Just for readability purposes I used 3 string commands. You really don't have to, but I decided that it's more clean like this. Now what this command does is treat the data from the file we created, x.txt, as byte array, and create another array with very specific members, 128, 64, 32, and so on. These are powers of 2. We will use them as mask values to check whether most significant bit is set, second most significant bit is set, third most significant, and so on. So we start a loop. For each byte and byte array we will check all 8 masks, do a binary end. If most significant bit is set, add numlock to the sequence, if not, caps lock. Then again for the second most significant bit, and again and again and again, so on, 8 times for every byte. And move on to the next byte in the byte array. At the end of the sequence, add final scroll lock request and save it into another temporary file called y.txt and enter. At this point we are actually ready to send the sequence, so we tell the device to start keystroke reflection. It will now expect the toggle sequence. We bring again the Windows online and send the final third PowerShell command to actually read the data from y.txt, which has this long sequence of numlock and caps lock toggles, and a final scroll lock to end the sequence, and actually tell host machine to send this data programmatically. It will take some time. Usually the process is quite slow. I will show you how it works on this example. It will receive the end of sequence marker, which is scroll lock, and save the file into username.txt. Overwriting is as necessary because we actually specify the name of the file explicitly in this particular case. And at the end, turn off all the LEDs to make sure that they are all in known state. Now let's see how it will actually work. I will now update the payload on PocketAdmin and eject. Now plug the device back in. You can see a first PowerShell, second PowerShell command, and now a third one, which is not obfuscated because it's just an example. You can see the LEDs toggling. It's over. Let's now go back into the storage mode to see what we got. In our case, we have a file called username.txt, exactly as specified, and our currently logged in user, which is just user. So it works. Cool, right? So what is the reason for me to say that it's not super cool at the beginning of the video? Well, the main problem is speed of the transfer. Essentially, if you look at this, you'll see we transferred only 4 letters. 4 letters which Windows transformed into 14 bytes because of the way it encodes data in PowerShell file. So we transferred 14 bytes, and if you look carefully, it took about 7 seconds to actually complete this transfer. And this is consistent with what I measured for bigger files as well. It doesn't matter whether PocketAdmin is connected or not, it depends purely on the host machine, and on my machine I'm only getting about 2 bytes per second. So this is what you're gonna get. If you have some kind of big quantities of data, like pictures, long text, or whatever, something that's more complicated than just a username, you'll probably be better off just outputting data onto a screen and making a photo or something like that. But hey, maybe if you actually indeed working with very restricted machines, you might find a use for keystroke reflection as well. So you can try this out and see if it works or not for you. More info on this, as usual, is available in the wiki, Keystroke Reflection. So let's move on to the channel update. And the news are this. I'll be retargeting my further work and my channel as well towards domestic audience. This year very well might be the last video for English speaking audience, just to complete the playlist. I do plan to translate some of those videos and all the further work, for example on my local track, which I soon plan to put on sale. It will be in Russian stores and the videos will be in Russian as well. The reason for this is not hard to imagine. You probably have noticed that my, let's say, Tindie store was closed for more than a year now. All the sanctions that were imposed on Russia in 2022 made it quite hard to deal with Western buyers and frankly killed a lot of desire to do so anyway. So if you choose to stay on the channel, keep this in mind. And goodbye, I guess.